Hello, everyone! Ever wondered how your favorite apps predict the weather, recommend what to watch, or estimate house prices? Well, it all starts with something as simple as connecting the dots, and that's the magic of linear regression. Linear regression is a supervised machine learning technique used to model the relationship between one or more independent variables, features, and a dependent variable, target, by fitting a straight line through the data points. Imagine you're running a lemonade stand, and you want to figure out how the temperature outside affects your sales. You write down the temperature and the number of lemonades you sell each day. When you plot these numbers on a graph, you'll notice a pattern. Hotter days mean more sales. Linear regression is like drawing the best fit straight line through these points to predict sales based on future temperatures. It's essentially a mathematical way to understand and forecast relationships. Using linear regression, we can create an equation. Sales equals 2.5 times temperature plus 0. This equation tells us that for every 1 degree Celsius increase in temperature, lemonade sales go up by 2.5 glasses. Our square represents the proportion of the variation in the dependent variable, lemonade sold, that is explained by the independent variable, temperature. If our square is close to 1, example 0.95, it means that most of the changes in lemonade sales can be explained by the temperature. If our square is low, example 0.3, it means that other factors, besides temperature, significantly influence lemonade sales, and temperature alone is not a strong predictor. Key characteristics of linear regression models. 1. Continuous predictions. Unlike classification models that categorize data into distinct classes, linear regression predicts continuous values. For example, it can predict sales, house prices, or temperature based on input features. 2. Target variable. The model predicts a dependent variable, target, which is continuous. The relationship between the dependent and independent variables is assumed to be linear. Three. Independent variables, features. Linear regression uses one or more independent variables to make predictions. These can be simple linear regression, one independent variable. For example, predicting revenue based solely on ad spend. Multiple linear regression, multiple independent variables. For example, predicting revenue based on ad spend, seasonality, and market trends. Four. Supervised learning. Linear regression requires labeled data, where each data point has both input features and a corresponding output, target value. The model learns the relationship between them during training. 5. Mathematical representation. The linear regression equation is In summary, linear regression is a fundamental supervised learning technique used for predicting continuous outcomes. It provides a simple yet powerful way to model relationships and make data-driven decisions. I hope this video has clarified the magic of linear regression for you. Thank you for watching.